Welcome to this explainer. Have you ever watched someone literally freeze up when they're asked to do mental math? Yeah, well, that is math anxiety happening right in front of you. But here's the secret. Mastering math is not about having some sort of genetic gift for numbers, and it certainly isn't about rote memory. It's actually a logical, step-by-step evolution from physical objects you can hold in your hand all the way to highly abstract thought. Today, we're going to unpack the specific structured progression required to master basic addition. By looking at the source material on this progressive blueprint, we can see exactly how the human brain builds arithmetic skills right from the ground up. Okay, let's dive into this four-part progressive blueprint that reverses engineers' math anxiety into a really clear structured pathway. We'll be looking at building basic number sense, then moving from blocks to visuals, mastering symbols and equations, and finally, tackling multi-digit addition. Starting things off with Section 1, Building Basic Number Sense. Before we can even think about adding, we absolutely have to firmly anchor the raw concept of quantity in the real world. This foundational phase is built on three crucial microactions. First up, fluent counting from 0 to 20. But listen, this isn't just reciting a song from memory. That leads us right into step 2, understanding quantity. This means when a learner sees the symbol 3 on a page, which is step 3, their brain must immediately and automatically translate that to exactly 3 physical items. The symbol, the sound of the number, and the physical amount literally have to become permanently linked in the mind. To actually forge that link, we've got to get our hands dirty with concrete manipulatives. By grouping items using blocks, buttons, or even pieces of cereal, we make the abstract utterly tangible. A learner creates a physical pile of 3 cereal pieces. Then they create another physical pile of 2. To combine those sets, they physically push those 2 piles together. Finally, they count all of them, touching each piece one by one, all the way up to 5. See, they aren't doing math in their head yet. They are physically experiencing addition in the real world. And this brilliantly illustrates our first major level up in the learner's journey. Section 2, From Blocks to Visuals. Once that physical combining is mastered, we step away from those tangible objects. We replace the cereal pieces and blocks with 2-dimensional representations. We draw pictures, sketching out tallies or simple circles on a piece of paper. You can't physically pick up a tally mark, so the brain has to work just a little bit harder here. This is also where we introduce a massive efficiency upgrade, kind of like a cheat code, called counting on. So instead of counting every single tally mark, starting all the way from 1, the learner is taught to start with the larger number, say 3, and simply count forward from there, 4, 5. To really help make this mental leap, the source material introduces the number line. As noted by the Organic Chemistry Twitter, a visual number line makes jumping forward during addition simple and clear. This is just a fantastic visualization tool. The learner visually finds that first larger number on the line and literally traces the hops forward by the value of the second number. It beautifully bridges the gap between counting scattered tallies and tracking a continuous ordered sequence. Which brings us to a massive abstract leap. Section 3, Mastering Symbols and Equations. Now, what's really interesting about this slide is the stark visual contrast. On the left side, we have our comfortable, tangible reality, 3 blocks and 2 blocks. On the right side, we have pure abstraction, 3 plus 2 equals 5. For a learner, making the jump across this divide is honestly like learning to read a foreign language for the first time. We're totally replacing words and physical objects with pure symbolic logic. To make that leap make sense, we have to explicitly define these new symbols. The plus sign isn't just a random cross on a page, it's an action verb. It is the mathematical shorthand for physically pushing those 2 piles of blocks together, just like they mastered earlier. And the equal sign is the grand reveal. It shows the total result of that action. By teaching these symbols as actions and results, the abstract equation maintains its connection to the real physical world. So the crucial point is mastering our baseline. And in our base 10 number system, the absolute most important anchor point is the number 10. To build real speed and fluency, learners must effortlessly identify pairs that equal this baseline number, 7 and 3, 6 and 4, 8 and 2. If a learner intuitively knows what makes 10, everything that comes after becomes infinitely easier. And hey, they won't end up counting on their fingers under the table as an adult. And this brings us to a really powerful academic concept. Decomposing numbers. This simply means realizing that a single number isn't some rigid, unbreakable block. It's totally flexible. The number 5 can be broken apart into 4 and 1, or 3 and 2. When learners use flashcards or fun math games to recall these single-digit sums automatically, they aren't just doing rote memorization. They're learning how to actively deconstruct and reconstruct quantities in their mind, right on demand. But this naturally leads us to a bit of a wall. What happens when the numbers get way too big to draw? I mean, what happens when we're dealing with 47 plus 35? You can't efficiently sketch out 82 tally marks. You'd run out of paper and, frankly, patience. The visual and physical tools we relied on up to this point are suddenly obsolete. Let's move to and see how this builds into our final stage. Section 4, tackling multi-digit addition. To handle those massive quantities, we rely on a very precise set of mechanics based entirely on place value. Step 1 is aligning the numbers vertically, ensuring the ones column and tens column are perfectly stacked. Step 2 requires calculating column by column, and we always start from the right side. Notice that we've completely abandoned the number line here. Instead, we're trusting the architectural, structural rules of the base 10 system to guide us through the math. And that brings us to the final and most complex mechanic of basic addition, regrouping, or as it's really often called, carrying the one. When a column's sum exceeds 9, we must carry that value over to the next column. Now think back to everything we just covered. This single action is exactly why decomposing numbers and mastering that baseline of 10 was so utterly vital. If a learner doesn't fundamentally understand that 12 is actually 1 10 and 2 1s, carrying the 1 just feels like meaningless magic. But because they followed the progressive blueprint, they know exactly why that 1 is moving over. Which leaves us with a really important final thought to take away from this explainer. We've seen how mastering addition requires a very deliberate, patient progression, from concrete blocks to visual tallies to abstract symbols to complex multi-digit systems. It really begs the question, how can this step-by-step approach of breaking down the abstract into the tangible be applied to learning literally anything else in life? Whether you're learning to code, picking up a new language, or tackling a massive work project, where are your blocks and where is your number line? Keep that framework in mind the next time you face a steep learning curve.